Okay, now we're doing problem 4, and they ask us to take the derivative of, or sketch the graph of this thing. So we know this, that f of 0 equals, well, 1 over the square root of 4, which is 1/2. So we know what the y-intercept is. We also know that the domain is limited. The domain equals the set x such that -2 is less than x, which is less than 2. And the reason that is because if x is anything, say, greater than 2, we'll have a negative number under the radical. If anything is less than -2, again, we'll have a negative number under the radical. So there's our domain. Now let's take a derivative. So f prime of x, and we're going to use the quotient rule. And when we square that denominator, we simply lift the radical off there, and we get 4 minus x squared. Now, we'll hold the square root of 4 minus x squared constant and take the derivative of 1, and that's just 0. So then, by the quotient rule, we'll subtract, and this time we'll hold the 1 constant and take the derivative of 4 minus x squared. Well, that's going to be 2 times, in the denominator, 2 times 4 minus x squared. And then by the chain rule, we'll take the derivative of minus x squared, and that'll be minus 2x. And the negatives will divide out, as will the 2's. And now, when we invert and multiply, divide fractions, we'll have x over the 4 minus x squared times the square root of that will give us a 4 minus x squared to the 3/2 power. Keep in mind, on this interval, on this domain, this denominator will always be positive. So when we set f prime of x equal to 0, we only have to look at the numerator, and what will take that to 0? 0 will. So our critical value is x equals 0. Now, let's do another graph, or a graph of that. And so we've got a critical value at x equals 0, and c prime of f prime of x equals x over 4 minus x squared to the 3/2. Now let's graph that. Oh yes, it's, yeah, let's graph that. And we've got a y-intercept at 1/2, so 0, 1/2. And we've got vertical asymptote at, or bound, but I'm going to make it an asymptote of 2, and -2. So x can't be those values. And our domain is from -2 to 2. So now we have to find, and by the way, we have a flat spot here because that's our critical value. And let's see, our let's look at the limit. See what the behavior is as x goes to -2 from above, and our function is 1 over the square root of 4 minus x squared. And that limit is, as x gets closer and closer to minus 2, and you square that, the difference between 4 and that value is going to approach 0. So this thing, the denominator is shrinking, so this total value is going to go to infinity. So now we know what the behavior looks like on the left. Let's look at the limit as x goes to 2 from below. So coming from this side to 2, and when we do that, we've got 1 over the square root of 4 minus x squared. And again, as x gets closer and closer to 2, like 1.99999, 100 factors of 9, that difference will be infinitesimally small. And so like 1 over a millionth. And when you invert and multiply, you get a million. Well, keep doing that. You're still going to infinity, you see. Okay, so there. Let's see. Our task was to sketch a graph using the calculus, and we just did that. We used the critical value, and we also looked at the limits as x goes to plus or minus 2 from above or below. And so we're done.